Hello, this is 4-2 fractions and ratios. So we're going to talk about fractions and ratios today. So first of all, what's a fraction? Well, we learned that fractions are basically division signs. So for example, 3 over 4, this fraction sign, this fraction line here, it means division. 3/4 is the same as 3 divided by 4. Okay? So for example, if we did that out there, 3.0, put the 4 here, right? 30. First up 0, and then 7, 28, 2, 0, 5, right? 3/4 we know is 0.75. 3 divided by 4 is 0.75. So again, if you didn't know that already, the line in the fraction means division. Okay, so now we're going to talk about ratios before we actually get into some of the actual stuff. So ratios are just something colon something else. So colons are like this, right? So we're going to compare two different values. So let's compare the number of triangles to the number of circles. So I'm going to write the ratio of triangles to circles. Well, that'd be 2 to 3. Right? There are 2 triangles and there are 3 circles. Now I want you to write the number of the ratio between the number of triangles to the total number of shapes. If you said 2 to 5, you'd be correct. There are 2 triangles and there are 5 total amount of shapes. That's the ratio that we wanted. So what do fractions have to do with ratios? Well, we can also just put the fraction sign here and say that 2/5 of the shapes that are in here, which in case there are 2, right, they're 2/5 times 5 is 2. 2/5 of the total amount of shapes here are triangles, right? This is the ratio of triangles to shapes. So can you write the ratio of triangles to circles now? If you said 1 to 4, that'd be correct. So it's not 4 to 1 because you want the triangle to circle ratio, not the circle to triangle ratio, which is different, right? 4 to 1 is different from 1 to 4. Just like 1/4 is different from 4 over 1. Okay, so now can you write me the ratio of triangles to the total number of shapes? If you said 1 to 5, you'd be correct. 1 triangle, 4 circles, that's a total of 5 shapes. Now, I want you to tell me what fraction of the total number of shapes are triangles. What portion of the total number of shapes do triangles represent? If you said 1/5, you'd be correct. There's 1 triangle and there are 5 shapes. So 1/5 of the total number of shapes that are being shown right here are triangles. Now, how about this? There are 2 circles and 2 triangles. What's the ratio of triangles to circles? If you say 2 to 2, you'd be correct. Well, that's also the same as 1 to 1. In other words, there's 1 circle for every triangle, right? So, for example, this circle right here to this triangle right here. In other words, both sides can be divided by 2, which would equal 1. So there's 1 circle for every triangle that exists in our hypothetical whatever. Okay, so now say we have a random spinner. Here's like our spinner, we flick it and it rolls to a number. So we have 3 sections, 1, 2, and 3. Okay, so I'm going to write the ratio of flicking it randomly. Say it randomly hits a number or lands on a number. I want you to write the ratio of on the number 2 it lands on the number 2 to the ratio of not on 2. So if you said on 2 is 1 and not on 2 is 2, 1 to 2 ratio, you'd be correct, right? 1/3 of it is 2, which means that it will land on, say, once in a perfect world if we flipped it 3 times, and it will land twice because there are 2 spaces that are not 2, and there's 1 space that is 2. So the ratio of on 2 to not on 2 would be 1 to 2. Now I want you to write the ratio of on 2 to total number of spins. Or in other words, what's the ratio of probability being on 2 and the probability of not being to just spinning in total, like getting a number. So 2 to a number. There's a space here, by the way. If you said 1 to 3, you'd be correct, right? 2 makes up 1 is one portion, and numbers make up the entire thing, which is 3 portions. So 1/3. Let me put a thing there. So that means that 2 makes up 1/3 of the spinner. Now, for example, say we had some dice. Oh, let's do 1 die for now. Okay, that's not a very good die, but say you roll the die. What's the probability? How many sides of the die are even to odd? What's your ratio to even to odd? Well, it's pretty simple. There are 3, so they're even, right? 2, 4, and 6 are even, and then odd 1, 3, and 5. So there are 3 even and 3 odd. Now I want you to write the ratio of even numbers to numbers. So the number of even numbers on the die and how many numbers there are on the die. If you said 3 to 6, you'd be correct. So there are 6 sides of the die. It's a cube. All right, 1, 2, 3, 4, 5, and 6. And there are 3 even numbers out of those 6 numbers. So the probability of rolling an even number, if you divide 3 by 6, that's 1/2, right? That simplifies to 1/2. So that's ratios. Here's another thing. Probability is equal to number of times it happened or will happen, which is over number of total. So for example, back to our die example, right? Say you want to roll an even number. There are 3 sides that are even, and there are 6 total sides. So the probability of rolling an even is 1/2. Of course, this is the theoretical. So if you go out and actually roll die, it may not be 50%. So you might roll even number 5 times and an odd number 8 times, right? That's not 1/2. That's 5/8. 5/13. So this is the theoretical. In a perfect world where probability is, or where theoretical values are the same as experimental values, you will roll 1/2. And also, as you roll more and more, like roll into like your 10,000s or your millions, you'll realize that the probability of you rolling an even number is indeed pretty close to 1/2. Okay, so now we're gonna actually use this probability thing to do some other examples. Say there's a bag, right? You don't know what's in the bag, but there are marbles. Okay, so there are 3 blue, 7 reds. Okay, so first of all, I want you to write the ratio of blue marbles to red marbles. If you said 3 to 7, you'd be correct. Now I want you to write the ratio of blue marbles to marbles in the bag. If you said 3 to 10, you'd be correct. There are 3 blue marbles and there are 10 total marbles. 3 plus 7 is 10. So there are 10 total marbles in the bag. Say you drew 1 marble. What's the probability of it being blue? Well, we know that our equation to find out is the percent that the number that it will happen over the total. In this case, there are 3 blues and there are 10 total. So that's our probability. 3 over 10, which is 0.3 or 30%. We have a 30% chance of it being blue. In other words, in 10 marbles, we will pick out 3 that are blue. Okay. We'll do one more example before we end this class off. So, say you and your friend are doing a guessing game. You pick a number between 1 and 20. And your friend asks you whether or not your number is even. And you say yes. I want you to tell me now, if he just randomly guesses a number, what's the probability that he will be correct? So 1 to 20, and it's even. So he asks if it's even. You say yes, it is even. And he chooses a random even number between 1 and 20. So what do you think? What's the probability that what's the chance that the number that he guesses is the number that you're actually thinking? So first of all, let's write the number of even numbers from 1 to 20 to odd numbers and even from 1 to 20. If you said 10 to 10, you'd be correct. Great. Now, can you write the ratio of even numbers to total numbers from 1 to 20? If you said 10 to 20, you'd be correct. So now let's plug it into our probability thing, which is the percentage that will actually happen to our total, which is 10. So there are 10, my bad. So we know that there are 10 numbers that he could choose from that have a chance of being right, because only 10 numbers are even from 1 to 20. So you already confirmed that the number that you're thinking of is an even number. So say he chooses one of those numbers and it's correct. What's the probability of that happening? Well, there's only one number that you can think of because that's how guessing games work. You can only choose one number. The number, you can only choose one, so there's only one number that he could choose that is correct. And how many different options does he have? He has 10. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Right? He has 10 numbers to choose from. So he has a 1 in 10 chance, or 10% chance, that's supposed to be a 10, 0, 10% chance of getting it correct. In other words, after 10 tries, he would have gotten it, because 10% times 10 is 100%. So he has a 10% chance, which is not a very good chance, by the way. So 50% is halfway, 10% is less than halfway. Okay, great. So that's all I have for you today. This topic is a bit trickier to wrap your head around. If you have any questions, feel free to ask. And the homework will be in Google Classroom, and it'll be a test on Friday, the last test. And yeah, enjoy.